Hello there, so this is another example wherein we have again three forces, but one force doesn't have an angle. And when one force doesn't have an angle, that force can be lying only along the x or the y. Okay, so for this we have F1, which is lying on the first quadrant, so that means x and y positive. F sub 2 is lying along the negative x, and F3 is lying along the fourth quadrant, and the theta is lying along the y-axis. Okay, so for this, we need to resolve the components of your F1x and your F1y. So solving, our F1x is simply equal to F1x is simply equal to F1 cosine of 35 degrees, and the answer is 81.9. And your F1y is F1 sine of 35 degrees, which is simply equal to 57.35. Okay, so they are both positive. So you will see that F sub 2 is lying along the negative x-axis, and F2x is negative 200 newtons, and your F2y is simply equal to 0. Okay, so that is the magnitude. Then you have your F3. Your F3x is opposite the angle, so it's F3 sine of 30 degrees, which is simply equal to 125, and your F3y is F3 cosine of 30 degrees, which is simply equal to negative 216.51 Newton. So you will see here that we need to find the summation of forces along x. So 81.9 plus negative 200 plus 125. So the answer is 6.9 newtons. Then getting summation of forces along y, 59.35 minus 216.51 newtons. Therefore, summation of forces along y is negative 159.16 newtons. Okay, so solving for the magnitude of your force, Fr is simply the square root of fx squared plus summation of f of y squared. Therefore, the final answer for your Fr is simply equal to 159.31 newtons. Okay, so getting for the theta, for the angle of your resultant, tangent of theta is simply equal to summation of f of y divided by f of x. Okay, so theta now will be equal to negative 159.10 divided by 6.9 shift tan. Okay, and your theta, you will get negative 87.52 degrees. Okay.